Okay, I think we're ready to start. We got a variety of things, not a lot, but a variety of things to look at today. Um, Probably some of them are going to cause a little bit of issues because they're going to stress out my computer, so I might freeze up the screen every now and then, have to restart the screen. Doesn't take very long, so if you see anything frozen, hopefully it'll come unfrozen soon. Um, but some of the stuff we're going to do, it's all running on the same computer, and it kind of gets a little bit much for the one computer to handle, including the streaming. So things might lock up. I think the voice stays no matter what, but the picture might lock up every now and then. All right, let's see. Let's go over to here. Let me make sure I can see what's going on. There we go. So one of the things, this is just a show and tell kind of deal. One thing was, I think maybe last time I showed you some dual color filament. Well, I printed this little guy in the dual color filament. So one direction he looks blue, and the other direction he looks green. So that's one of the things that, and this is also a silk, so he's shiny. I don't know if I can get him close without it kind of going, I don't know if it'll focus right there. Maybe, that's too close. So this is what the silk filament can look like with the shiny texture on it. And it's totally fine. I mentioned last time that the silk is sometimes a little more brittle. I said brittle, but it's not really brittle. It just doesn't hold the layers together quite as well as a regular PLA. But, I mean, it's fine for general handling. It's just if it's under a load. So if you were making a bracket or something out of the silk PLA, that's probably not the best idea. But it is a pretty cool filament type to use. It prints exactly like PLA. This is PLA, but it's just a silk. And you can find all different colors. This is one of the two color ones, so blue in one direction, green in another direction. It's a little bit difficult to control, you know, is the front going to be blue and the back going to be green, or is it going to be blue on one side and green on one side? You know, how exactly is it going to come out of the nozzle? But depending on your filament path, you know, how many twists and turns are on your filament path, you might print a little test block and see what's going to happen. And then, instead of trying to do anything with the filament, just arrange the model in the orientation that you want. So you want blue and green, or do you want blue and green on left and right, or diagonal, or whatever. Just arrange the model in your slicer. Don't change anything with your filament path, and it's pretty consistent once it's set up, that, you know, it's all blue in one direction and it's all green in the other direction. It's pretty consistent throughout the print once you've got it figured out what it's going to do. This one, I just printed it, and whatever happened, and it happened to be that it was blue on front and green on the back. Oh, I have the chat covered up. Let me make sure I'm not missing anything. I don't see anything over there. All right, so that's one way. You don't have to have any special printer. There's nothing special about it at all. It's just the filament, and there are different types of this. So I mentioned this one is a dual color. Obviously, there's all sorts of color combinations. There are tricolor ones, so there's 3 colors in there. There are transition rolls where they start one color, and as the roll gets used up, it moves to another color or several other colors. You know, there can be like a rainbow of assortment of colors. And so there's different ways that you can add color to a model without having to have any kind of special printer. This one is a special kind of printer. So this is a multicolor model. This is all one print. It's not painted, and it's not like glued together. So it's all one print, and it's 3 different colors. There's a white, a black, and a blue in there. And so for this kind of model, what you end up needing is some kind of special printer or special attachment for your printer. That one, the little shark, came from a Bamboo Lab X1C that has the AMS, I guess that's automatic or automated material system. Not sure what it stands for, but what it is it is a box with 4 different rolls of filament in it, and the machine, based on what your slicer is telling it, can select which filament it wants to use for that particular line on the model. So it selected between these 3 colors, and when it needed a new color, it would retract all of the filament that was previously being used and feed in new filament. So the downside to that is it's way slower. So printing this little shark by itself without the multicolor would probably be, I don't know, on that printer maybe an hour or an hour and a half. But when you have to, maybe not even that long really, it's kind of small. But when you have the color changes, I think it was over a 5-hour print. Plus, most all of those printers, not all of them, but most all of those printers have to purge because they're using one nozzle, and all the different colors are coming out of that one nozzle. And when it removes the filament, the previous refilament from the nozzle, it doesn't get all of it out, so it has to purge out the filament, particularly like when it's going from light, like the white, to the black, like the eye. It would have a little bit of bleed. It wants to make it gray, something like that. So this one it purges, so it just spits out filament, and it uses a prime tower, this little guy, to make sure that there's none of the previous filament in there. Now you can optimize that a little bit to make it less of a burden, but this one, I weighed them. This is 0.2 ounces, and he's only 0.3 ounces. So the amount of filament that you just waste is almost equal to him. Now the good thing is, if I were making a bunch of these little sharks, I could fill up the whole plate, build plate with 20, 30 sharks, and I'd still only need this one purge tower. They'd all print simultaneously, and well, not simultaneously, they'd be sequential, but all the layers of blue would happen, and then it'd purge to get to the white, and then it'd do all the white for that layer, and then it'd purge and get to whatever other color was in that layer. So it does add some waste. Now there are things you can do with the waste, like you can actually print models in the waste. You can try to purge in the infill so that it's using the infill of the model that you're not going to see anyway. It can use that as some of the purge. Prime tower, but there is that associated with it. Also, it only works on printers that have some multi-material system, and there's several out there now that do have that. You can do really unique things with it too, maybe 2 different materials, and one of them is just used as a support material for the other one, so it just peels away, or some supports can just melt away, like they dissolve in water or other chemicals. And so there are some other like actual uses other than making a fun multicolor model. So I just thought I'd show those things because those were something interesting. Oh, I'll show this one too. These are, this is print in place, meaning that it's all one print and it's articulated, so you've got movement in there. There are ways to print models where it's all one piece and it's already all connected together. Also, I did print this. So this little guy, this is not a print in place. This is a multi-piece. So the plane is actually 2 pieces. It's got a little ballast type weight down there. Plus it's the sled that goes in the launcher. The launcher is 1, 2, 3, 4 pieces with a rubber band in there. But they're printed separately, and you assemble it, and it's all snap fit. So there's some pretty cool stuff you can do with multi-piece models too. So this one, you pull it back and you load in the little plane, and I guess it's going to go, I don't know where it's going to go, but it goes off somewhere. It hit the wall over there. So there are some like functional prints. I'll show you a really cool one some time in the future. It's over. It'll be for another day. But it's a really cool functional model. Let's see. I see some comments. Let's see what they say. If I can find the mouse. Oh, it's just a hello. That's good. Would it be possible to do a multi? Yeah. So the multi-material print on A1 Mini. So I have the Bamboo Lab X1C with the AMS, but they have other printers in the Bamboo Lab system that also can use AMS, and the A1 has a different AMS system, but it's the same idea where there's 4 spools, and you can do multi-material. The one thing you have to worry about with multi-material is some materials have very different printing temperatures, and since you're using the single nozzle, Sometimes it has to heat and cool between filament changes, and sometimes it can get a little bit tricky because the hotter filament might stay down in the nozzle, and when you go to print the colder filament, the cooler one, it may not be able to melt and purge out some of that hotter filament. So it's a little bit tricky with some materials, but there are other materials that do work. They're close enough in the same temperature that they don't really have problems purging the other temperature filament. I'll see if I can find it. There was a really good website that had different combinations of this filament will actually adhere to this filament. So these two will actually work together and become one model. And then they have also, there's some filaments like, I think TPU and PLA won't stick to each other. So you can actually use PLA as a support material for TPU. TPU kind of has trouble with supports because TPU is the rubbery filament, in case you weren't certain of that. Printing rubbery supports is kind of a problem, but if you have a way to print the two of them together, then you can use PLA as a support material for TPU, and then they don't stick to each other, and so that's actually advantage of not sticking together. Can you print multicolor with a printer that does not have a multicolor system? Yes. So we actually will do that, not today, but we'll show you how to do multicolor. Now, the one thing with multicolor on a single nozzle without the multi-material system is that the colors are in layers. So you can still get some really cool effects, but it wouldn't be like, drop stuff. It wouldn't be like this one where they're all embedded in the same layer. Each layer has to be its own color. So you can still get some really cool stuff. And there is one, I'll show you one system that is pretty cool, and they kind of mix the layers together. But there are ways that you can have a single filament system. There's a fly buzzing around. And one nozzle on one printer and get some multicolor models. So there is a way to do that. Have I had any? I don't have an A1. So I know people, and I've seen A1s, and they've been great. And they say that they're a little bit smaller than the Ender 3. So if you're planning on printing large stuff that's going to be larger than the A1 bed, they're not tiny, but they're smaller than the Ender 3 bed size. Other than that, I think they're really great. The other thing with them is they're a cantilever system. I think the A1 Mini is anyway. And so that means that this bar here is only supported on one side, and so it can't. That's why it's a smaller printer. Part of the reason it's a smaller printer. This fly is really annoying me. But I have not heard people have problems with the A1 series of printers at all. And they're a pretty good set of printers. And other brands, I think Creality has an AMS system. I haven't used it at all. And I think there's one other one that has an AMS system. I don't know if they all call them AMS, but there's another one. And so that's more like a show and tell than anything. Maybe we'll do something with that later. We will do the single printer, single nozzle, single color at a time, and we'll do that as far as how you can get multicolors out of that system, just like this Ender 3 here. We will do that. Oh, all right. So does printing with ABS require enclosure? Require, not exactly, but there's a couple of things. So ABS, it's a good material. In fact, the original. Let me show you this. I was going to show you this. This is the first printer I ever built. Right here, a picture of it, not the actual one. That one, yeah. There's the first printer I ever built. And so these were, if you can see in the picture, this is all thread from Lowe's. There's some pieces here that you would get from places like McMaster, and then all the orange stuff is 3D printed from another printer. And so this is what printers used to look like. Back in this day, most of the filament you had available was ABS. So that blue filament right there, that's probably ABS somewhere. And originally, a lot of the original, not commercial printers, but the ones where people were kind of hacking together their own printers, like this one, it was weed eater line. So that was the only thing that was really, you couldn't go to a store and buy a roll of filament, but you could buy a weed eater line, and that's kind of how the sizes, the 1.75 and the 2.85 sizes of filament, that's kind of where it came from. But anyway, all that to say that it used to be that kind of all you had available was ABS. And there's two main problems with printing ABS without an enclosure. The first one is that it probably, if the part is large, it's probably going to rip apart. So we talked several classes ago about how the stresses in a cooling plastic want to make it contract, and so that it can warp and peel up from the bed. Well, in ABS, those stresses are really strong, and they'll actually peel layers apart. And so you usually need the enclosure to keep the heat in. In fact, a lot of the printers that print ABS have a heated chamber, so that instead of just ambient air plus whatever your heat bed is doing to heat it up in a chamber, it's actually adding extra heat to the chamber to try and keep the air around the ABS warm. Actually, some of it's kind of hot in some of the commercial printers. So that it will cool slower, so that it doesn't want to peel apart that much. The other thing, that let's say that you're just printing little small pieces and they're not pulling apart, you've kind of, maybe you have one of the chambers, there's one right here. Is this it? Yes. So maybe you have one of these 3D printer enclosures. Obviously this is just the box that one would come in. But inside here it's kind of like a little miniature tent. It's got little tent rods in it, and it's a canvas material. Some of them have a reflective material inside to kind of trap the heat in there. That will help some, but that's the first problem, is that the air around the print itself needs to be pretty warm so that the ABS cools slower, so that it doesn't want to pull itself apart. The other problem is that usually ABS it's not a nice material to be around breathing while it's printing. It doesn't smell very good, and usually if stuff doesn't smell very good, it's harmful to you. And it could be, there are all kinds of studies out there that indicate potential long-term harm. None of them are definitive that I've seen, but potential long-term harm if you were in a room full of printers all printing out in the open air and there's not a lot of circulation in there. You could absorb like micro or even nano particles from the print. So that's another reason you usually want to print ABS in an enclosure that's off somewhere else. It's vented to outside, or it's in a totally different building, especially for printing stuff like that. So if you're printing little tiny parts, you could probably get away with putting the printer in one of these. This little bag, this little printer enclosure like this one is, you can probably get them in the $30 to $50 range off of Amazon. Other people make their own printer enclosures out of anything that will go over the printer, like a bag or a cardboard box or whatever. I would, if I were serious about it, I would get one of the enclosures off of Amazon for $30 or $50. They make fancier ones, but just get one of the canvas ones, so that you could at least use the heat bed, trap that heat in there, and you could contain any kind of fumes, and then you could exhaust them somewhere else. So it can be done without an enclosure, but it really only works with really tiny pieces. Otherwise, the parts are going to rip themselves apart. All right, I think we're caught up on questions. Let's see, what else do we have over here? I think that's all the show and tell things. We were working on this. So I don't think we're going to model this whole thing, but this is the one of the missiles. I have one of them for our X30. Well, I can't reach it right now. It's on the other side of the room. But the G.I. Joe Conquest X30, we've got one that's missing most of its parts, and I have little bits and pieces of parts. So far we've made the rear wings, and we've made the front canards, or canards, I don't know exactly. I think it's canards. And next I was going to work on this missile. Now I don't think we'll finish it all today because it's a little bit, I'm going to show you maybe not the ideal way to make it, but just to show you a different piece of software that I do use. It is not like Fusion and it's not like SolidWorks. It is a Boolean model system where basically you take primitive shapes and stick them together and cut them apart. And it is, I use it a lot of the times. It's called Tinkercad. Let me get over there to Tinkercad. So it is free. You do have to register with Autodesk. Let me get to the right, that one? Yeah. So Tinkercad.com is the website, so it's above your screen so you can't see it. You do have to register with Autodesk for a free account, and just so you can log into it. It is completely online, so you do have to have internet connection. I don't even think it's possible to download it and run it locally. There might be, but I don't think it is. The reason I like using it is because it's super fast, and as long as I just want a simple part, I can make the part here faster, get it exported as STL and already slicing before I can do a lot of stuff in other more sophisticated true CAD modeling programs. So I do use it, and we're going to use it a little bit today. It's this modeling this little missile is probably a little bit at the upper end of Tinkercad's ability, for me anyway, because I could probably make it faster in another piece of software. But I'm just going to, part of this class is to show you many of the different ways that you can do stuff. And so this is one way you can do stuff. Let's see what all this. ABS, yes, ABS fumes smell bad. Let's see. Yes. And then talk about resin. We will actually do some resin printing later in the course. Yes, and Tinkercad is web browser only. So you can't download it, which in my case, that's why I use it sometimes, is because if I'm on a piece of hardware that doesn't have SolidWorks, or doesn't have Fusion installed, then you can go to Tinkercad and at least bang out a little part pretty easily. So, I think what I'll do with this one is in the other one, and we made the wings. I made the canards offline, but they were the exact same process as the wings. What I did was I took my phone wherever it went, took an overhead picture with something to scale. So I think I either did a ruler or a grid, and then brought that picture in to Fusion as a reference image. So you can kind of do that in Tinkercad, but the image is important. Like, it's very limited on what kind. You can't just throw a JPEG or a bitmap or a PNG in there. It will only, as far as I know, take a SVG file. So SVG is a vector file. So what that means is, instead of like pixels, it's an equation, a set of equations that define the shape. So if you take a picture with your camera, that's not going to be a vector image file or a vector graphic. So here's what I did. So one thing we could do is we could just measure, right? We could just measure everything and create the model that way. But what I did take a picture of this guy, overhead picture, and it's mostly symmetric. There's a few asymmetries, like this little slot where it actually attaches to the jet is different on one side than the other, and it's a little bit taller. The main body of it's taller than it is wide. So that's one other little difference. Are we going to capture all that? I don't know. But here's what I did. I took that picture, and it was a regular, picture from a cell phone, and emailed it to myself, and I went to a site called Photopea. So Photopea. So here, let's see, here we are, Photopea. So this is like Photoshop, but it runs in your browser, and it's free for most things. There probably is some like service plan you can use to get other features, but I don't need any of those for this. So this is another one of the, hey, you don't have to use Photopea, but it does run in your browser, and it is free to use for what we need. So And I don't know, there is an account button, but I don't know if you have to have an account for it or if you can just run it. I don't actually remember. It might have automatically logged me in. I don't remember logging into it, but I think you can create an account. I just didn't. All right, so what we're going to do with this, the dogs have found an interesting thing. File, open, and we're going to open the pictures. This is a picture I took. So I just put it on a white background in this case because what I want to do is I want to turn this regular camera picture into a vector picture. So first I'm going to crop it. So let's see, yeah, you can see all the tools on the side over here. I'm going to use the rectangular select and crop down to something like that. So I just selected that and then image crop, and now I've just got the part I'm interested in. Whoops. The keyboard shortcuts are different on all these different pieces of software. So now I could probably spend some time balancing the colors and getting rid of this highlight and all that. I'm not too interested. I just want the general shape. So I'm going to call this good, although it's not actually good if you wanted a vector image. And I'm going to go to image and vectorize bitmap. Even though this picture I think is a PNG file, it doesn't matter that it doesn't have to be a bitmap. It just needs to be a pixel-based image. So it's thinking. So over here on the left, that's the picture. Oh, I guess I didn't apply the crop. Let me go back. I thought I did. Huh. I don't know. All right, well, it doesn't matter. I don't know why it didn't crop. I guess I need to save it and reload it. I don't want to do all that. So over here on the right hand side is the vector, and you can kind of see, probably it depends on your screen. You might can't see the blockiness of it. What it has done is it's taken the full color image and dropped it down to, I think it's down to 20 different colors. Now I only want 2 colors. I want the missile and the background. So I'm going to change colors to 2. It's a little laggy. There it goes. And now now it's inverted from what I really want, but it'll be fine. Now I've got a preview of what the vector image is going to look like. It's not perfect, but it's close enough to get me what I need. So I'm going to click OK. So now I've got a 2 color. Now it is back to cropped. I don't know why it had to crop or vectorize the whole thing. And I'm going to file, export as, and there's my SVG file. I need that vector file. I support vector graphic, or I don't remember what the S is. But I need that for Tinkercad. So I'm going to do that. Leave all these options. You can change the size if you want to, but it's not scaled in any meaningful way, so I'm not going to worry with that. I'm just going to, actually I want to save it on the desktop. Oh, no, I'm just going to download it. So file, export as, SVG, save. And it went to my downloads folder. All right, so we're done with PhotoP. We can close that out. You can save. I think in order to save in their system, that's when you have to have an account. I don't need to do that because I'm done with it. So now we'll go back to Tinkercad. And let's see if there's any... oh, okay, yeah. Oh, Maker Lab. I didn't think about Maker Lab. Yes, so Maker Lab is the Bamboo Lab tool set. They've got all sorts of, we'll use some of them. They've got all sorts of AI based tools, other types of tools also. I think they have a system there that can create multicolor models for one nozzle, one roll of filament at a time, printers also. But yeah, I didn't think about that. They have a photo to STL thing, which wouldn't really do what we want in this case, but there are some ways. Which is not what we're doing right now. All right, so I'm going to create a 3D design. Oh, look, you can actually, oh, it's off your screen. So it's over here. There's a create button. So it's off. I don't know if I can make it fit on the screen or not, but there's 3D design. You can also create circuits and blocks of code. So we're going to do 3D design. me make sure that all of these are showing up on your screen. They're not. Let me do this so that you can actually see all the buttons. All right, so my picture there is actually covering up some of the things I need to, got to temporarily move where I'm at. We'll go down to the corner. All right, so up here is import, and we'll choose a file. We'll go find that SVG file. This is it right here. If you know the scale, you can do that. We don't know anything, so we're just going to import it. And it's going to be backwards from what we need. But, and it's giant, right? So it's more like the outside of what we need. So if I wanted it to be the other, I'd have to have inverted the colors and all that. I'm not worried about it. I just want the outline. It is too big though. So the best way I know to scale it is this thing is more or less, you know, it is, I measured it. Let's see, I've forgotten the measurement though. Just going to take calipers and measure it from end to end, 123.5-ish millimeters. So from end to end, 123.5 millimeters. So what I'm going to do is I'm just going to put a cylinder out here. Oh, so Tinkercad, we're in Tinkercad now. So over on the right hand side, and it put me back up there covering up a lot of the stuff. Let's go over here. Over on the right hand side, these are all your buttons that you can use. And the way Tinkercad is set up is you have a lot of primitive shapes. You have, you know, there's more shapes down here. There's all sorts of like particular things, vehicles and machines, all these different things that are ready pre-built. We're just going to use the basic shapes. So I've just grabbed one of these, I clicked on it and dropped it in here, and I am going to manipulate it so that it is basically the length that I need. So I'm going to turn it sideways. So you'll see it's got these little curved arrows, and you can tell it, oh, let's see, I'm in inches. Let's go into millimeters. We want to be in the metric system. I said 123.5. So that's the length it's supposed to be. So what I can do now is I can kind of get an overhead view, and we can zoom out really far because it's way too big. And then we can, oh, whoops, hold on. I need to uniformly scale. So hold down Shift and scale this thing until it is the right length. Somewhere in there. Zoom back in. Still a little bit too long. That's pretty close. All right, so now we've got more or less the right length for this thing. We could probably make this smaller and be more, I'm not too worried about it. But now what I've got is I've got the basic shape that I need. So there's a couple of approaches why I wanted the outline here of the missile, the picture of the missile is there's one tool in here, it's called the sketch tool. It's this little, looks like a ink pen type of thing. And what it lets me do is it lets me sketch based on an outline. Or, well, you can sketch freehand too, but if you have the outline there, then you can more or less just trace it. So let's see. So it's snapping to this grid, which is a little bit too gritty. Down here, I'm going to go down and make the grid smaller, so I can snap to some of these points I want. Still can't get the exact one I want, but will be good enough. I could keep dropping this. I could turn the snap completely off, I guess, and then I could get exactly what I want here. And now the vector image has not made exactly what is in here, so you might have to refer back to this to see what's really going on. We're just getting close. It's going to be fine. This one is pretty squared off. It does have a little bit rounded corners, but it's pretty squared off. And if you hold down shift, it snaps to certain, angles. So if you want something to be perfectly horizontal, although that doesn't quite look like it is, but it does on the model. So we're going to go on the actual missile. There, there, and then we're going to do this, 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 and let's see, I don't know where we started at. I think we might have been right on that line. I should have paid attention to that, but I don't think I did. And then we can close it off. And so now I've got a closed shape. And I'm, this little tool right here lets you modify the selected shape to make it, if you want any of these edges to be curved instead of faceted, straight lines like I did, you can modify that. Again, we're fine. So now let's move that out of the way for now anyway. Way too thick, but look at this. I can click on it, and these handles have the dimensions. Oh, look, it's a little bit too long, so it's supposed to be 123.5. So there. This one is how thick it is. It's definitely not 10 millimeters, it's 2 millimeters. So now I'm starting to get the basic shape, and I can copy that, control duplicate, and I can mirror it across this way, and then I can pick one of them, not both of them. Why is it? There we go. Now I've got them kind of all. I could try and eyeball line them up, but there is a tool here. If I select two different things, so I've got this side and this side selected. I just held down shift to select them both. This little tool called Align with the shortcut key of L will let you align them in a lot of different ways. So I want them both at the same base. That looks good. And then I'm going to use the arrow keys. Actually, I'm going to have to turn snap on to something. Let's do 1 millimeter. And I will line these up. Now they're overlapping a little bit, too much for my liking. So let's go to 0.1 millimeter. There we go. All right. Now it looks like I did not get my line exactly straight there, so they're not quite perfect, but again, we were going relatively fast, and I don't think it's going to be a problem. So now I've got these two pieces. I can select both of them, so hold down shift and click on them, and then this tool is grouping, and now they're one piece. And then I could duplicate that, and now I've got this one. Actually, let's move it with the arrow keys so that it stays in the same alignment. And then we'll rotate it using our little rotate button. There, and we'll put it back. And now I'm getting really close to our missile. Pretty quick. Now it's got problems, right? Like look at the, like that's not right. So you've got some problems in there, but it's not horrible. In a pinch that would do. Now this one, it has these, or there's 4 of the tail fins, which I have, but there's only 2 of the mid body fins, so I don't need this piece over here, like this piece over here. So to get rid of that, there's a couple of things I could do. I think what I'll do is these 2 tools with the stripes on them, those are cutaways. So I'm just going to drop a block on here, and I dropped it right on that surface, and so anything it overlaps with is going to get removed. So if I select it and select my missile body, now when I group them, it's going to group. Oh, did not group. Why did it not cut that away? Oh, I selected the wrong thing. I never grouped the whole missile. All right. And I didn't get it perfect. There's a little little ridge there. I could go and worry with that, but I'm not going to. And then I do the same thing on the bottom over here. Put that guy, make it overlap the wing there, group them together. Now I'm getting really, really close. Now it's not perfect, but it's pretty close. I do need this little set of mounting holes. I don't know if they showed up in my... Oh, they do. Look, this is them right there. You can kind of see where they're at. We could use this again, possibly, if we can get it lined up. Looks like it's a... Oh yeah, I scaled it, didn't I? I scaled it only in this direction. That's pretty close. You know, again, not perfect, but we're not going for perfect right now. We can raise it. Oops, the wrong button. I think that one raises it up so that we can actually see those little slots. So now we know roughly where they are. We could measure. They look like, let's see. Here you go. They look like a 2 holes and a slot between them. So let's go back to there. And there's a hole right there. It's way too big. But we could measure it or we could eyeball it. We're going to do some eyeballing. Actually, I do have my calipers right here, so this does need to fit with the actual plane. 2 millimeters more or less. Oh, I see. We're missing a piece. This area has, instead of just being the thickness of the fin, there's like a cylinder there. So we do need to put a cylinder in there before we go cut this thing out. Otherwise, there's no material to remove. So we need a little cylinder. We'll start it on this. We have to turn it sideways. We've definitely got to scale it down. So I think this is probably 7.75, and the other direction is 5.34. We'll call it 5.4 just to give it a little more room. And then we need to center this guy on our missile. So let's, do we want to try and manually do that? Let's get this out of the way. All right, so one thing we haven't done is join these two. Let's join those. Okay, and then let's use our alignment tool to center it. So this one will center everything so that it's centered. Again, it doesn't look perfectly centered though, does it? I think we can eyeball it better than that. But we need a little less or more snapping. There we go. And then let's drop it down. It more or less lines up with the top and bottom, so we do need to squish it a little bit. Let's do 7.5. And then it needs to be even thinner, or yeah, a little bit thinner than that. Let's do 7.2. That looks really close, but I'm going to go to 7. All right, so now we've got our little barrel pretty much lined up. We could fiddle with it again, but we're not going to. We're going to say that this is pretty good. And it looks like it more or less goes there. So we'll group this guy. Now it's orange. Whatever color the object you selected and you group, the whole thing becomes that color. If you want multicolor pictures, then you have to change there's a little setting in this window up here where you change the colors. All right, so I think you get the idea of how Tinkercad works. Let's make this 2, 2, and then we'll try and we have to turn snap off. Looks like it was more or less there. Oh no, it's going to be more or less there. We'll duplicate this guy, and then we'll use the arrow keys with 1 millimeter snapping. Nope, 0.5 millimeter snapping. Pretty good. That looks more or less where it's supposed to be. There are a certain depth, and that depth is 5.8-ish millimeters. So let's just make them 5.8. There we go. And we will select both of them so that we can move them together. And we'll just try and line them up with the top surface as close as we can. Make sure they're not poking out the bottom. Oh, I do see something here. We'll talk about that in a minute. All right, let's get that thing out of the way. Actually, well, let's not delete it because we might need it. And then we need to put the little slot between them. We will also just eyeball that one, I think. So obviously you would probably want to take a little bit more care when you're making this than what I'm taking. That slot is 1.75 millimeters. And then we'll need to kind of get it lined up. Looks like we might need a little bit shorter. We need to make it that same 5.8 tall, and then drop it down to the same height-ish. Select everything, Control A. Oh wait, no, don't do that because that includes our SVG file. So let's just manually click, group, and now we've got our little slot in there. What I was going to show you is this cylinder. Look at the little stripes in it. So one thing about Tinkercad is that when you bring something in, it has a certain number of sides to it. So 48. If you don't like that, it's too rough for you, you can actually change that to a more or less number to get different shapes out of it. So if you want it smoother, you can run the sides up, apparently 128, and now it looks very smooth. You can still see the little facets in there, but they're much smaller. Or maybe you want it to be, very faceted. You can do that too. That's with any of the curved. So the cone and the cylinder and the sphere, you can do that with. So there's other little bits that we could go, we've got some weirdness back here. There's some weirdness up here for sure. And you could start trimming away, trying to line things up better than what we did. But in just a few minutes, you've got a decent representation of our little missile. Not perfect. One thing Tinkercad doesn't do that I wish it did, but I wish I could go in and click on one of these lines and fillet it. So round it over. Tinkercad doesn't let you do that. It does have, and it doesn't always work, but it does have send to. So there's a button slightly off the top of the screen. Let's see if I can. There we go. Send to, and you can send it to Fusion. Now, the process of the Tinkercad model getting over to Fusion does not always generate the model that you want, but it is an option you can try, and you could send it in there, and now you have access to your fillets and all that kind of stuff. Doesn't always work, but sometimes it does. So there are more little details on here. There's these little rings around the missile, stuff like that. But if we were just trying to get a missile model and we didn't want to try and figure out how to model it in any of the fancy software, you can get decent results in something like Tinkercad. Once you're done, once you're happy with it, you select the thing you want, export, and you can export it. Again, you can send it to Fusion, but you can export it as a STL and send it to your slicer. Now, one thing about this particular model is you do have to figure out how are you going to print it. Are you just going to put supports on it? Are you going to slice it in half somehow? So there are some questions about what are you going to do when it actually comes to printing it. What I think I will do is I want to show you one other thing, at least to get started, and then we will I'll probably clean this up a little bit, try to get it a little nicer, and then I think I will cut it right here. So I think I'll cut it in 2 pieces in the slicer right there and print those 2 pieces. I do have some little issue here with overhang. The other thing you could think about doing, I don't really like this for this part, but you can cut it in half this way. So like that. And you can print it and try to glue them together. I think they'd be too thin, like they'd only be 1 millimeter thick where the wings are, because I made that 2 millimeters. So that's probably not what I want to do, but that is another option for printing something without support, not having to deal with support. It's just so thin, I don't know that that would work very well. I might try it and see, but I don't know how well it would work. So we do have to figure out, well, how are you gonna print this thing? So there's a couple of different options. I think I'd like to print it standing up, although you do have to think about when this is printing. Now this one is very, like, it's a rubbery plastic, so it's not like a rubber, but it is very flexible. So we don't have a material exactly like that. There are some resin materials that are kind of bendy like this, but FDM melting plastic, there's not really a material like this. TPU is flexible, but it's a little bit more flexible than this is. There are some flexible PLAs that might be similar to this one. Maybe we could try that. It would have to be one of the more stiff, flexible materials if we wanted it to do this kind of thing. So I don't know. And that would, some of those TPUs are hard to glue together just with the material they are. So I'm not exactly sure what material we will print it in, but what I was thinking is if I do print it flat in 2 halves, now all the layers are going long ways, and so that does make it have more resistance to this kind of motion. If I print it standing up, all the layers are, going here. Any little bend like this is probably just going to snap it apart. So maybe it's not such a bad idea to print it flat in 2 different halves and try to glue them together. That might not be such a bad idea. It will sort of have an alignment because this little slot will go through the top half and go into the bottom half, so maybe there's a way to align it that way. Maybe we can make a little tool. Anyway, we're not going to print this exact one. I want to clean it up a little bit and slice it in half and see what we get. We'll see what we get. The other thing I wanted to show you, which this will just be the intro to it, and then we'll use it in the next class, is there are some pieces on the next pieces I think that we need to make for the jet don't really lend themselves to something like this, taking a picture of it and throwing it in Fusion or Tinkercad or whatever and tracing the outline. They don't really work that way. Let me get the thing. So doesn't fit. This piece in particular, if I took an overhead picture, it would kind of just look like a rectangle, and that's not the true shape. It's all curved everywhere. So what I need to do here is I need a better representation of this geometry. Now, this is going to require, for what I'm going to show you the way to do it, there's a couple of ways, but we need to scan that shape in. And so I do have a couple of scanners. So that's something that if you don't have a scanner, there is another way you can do it. It's just not quite as good. But we're going to assume that for whatever reason you have a scanner. I'm going to show you what the scanner does. The scanner that we're going to use is this guy. This is an old one, so if we can get the writing the right way. Revopoint POP. This is the original one. They're on 3 now, and they've got a whole line of other scanners, which I do have a much fancier scanner, but I'm pretty sure that it's going to not work while the computer is also streaming, because it takes a lot of resources from the computer for it to work. This one probably will crash, not crash the computer, but crash the video of me, of the camera video. The screen video should be fine. So what we're going to do is we're going to try and scan. So we've got Grant Hill here, and we're going to show you how this kind of thing works. So this particular scanner, what it's going to do, you're not going to be able to see it, but what it's going to do is it's going to project a grid onto the figure here. This figure is going to be rotating on this platform. It's going to project a grid onto it, and there are cameras on the sensor that are going to detect that grid. So if it projects a rectangular grid, I don't actually know the shape the grid is, but a rectangular grid, and it sees like a curved grid bouncing off of whatever you're scanning, then it can interpret those curves to mean the shape of whatever it hit. So it's called structured light scanning. So it projects a known shape. That shape gets deformed on the surface of the thing that's being scanned. It measures that deformation and then interprets that as, oh, well, I projected a straight line. It looks like this kind of curve here. That means the geometry that it hit must have had this shape. So that's the general process. I want to close down some stuff here to give it as good of a chance as possible to actually run. So give it as many resources as it can. And we will see if, let's see, I guess I don't have the software running at all, do I? Nope. All right. So let's get the software running. This is Revopoint, so it's RevoScan is the software. I've got it plugged into the computer just by USB 3, so I don't have a USB-C cable that will connect with it. It does think it's connecting. All right, it is connected. Oh, and it disconnected. That's probably what's going to happen a bit. You'll probably hear lots of connecting and disconnecting because it's just a lot for the computer to handle. So hopefully we'll get something going here. I've got to set up a project for it. So I'm just making a folder on the desktop so I can find it. Once we get, all right, so here's what the software looks like. Where can I put, gotta see where to put me that's not covering up too much. There's nothing much down there. Let's make it smaller so that you can see more of it. All right, so you've got several things. Over here in the left corner, there it is, disconnecting, and it's going to do that. Normally it doesn't do that if you're not also doing a bunch of other stuff. So I'll have to wait. What was in that corner is like a preview of the exposure. So here, I've got it set to auto, but you could go in and turn auto off and try to get the most exposure you can without overexposing. So those red dots you saw on the figure, those were overexposed. Down here, I've got for the color. So it will also, well, there it went. It will also collect the color information like the texture. I don't really need that, although it might be useful. I'm going to, I'll let it auto expose the color, but we probably won't actually capture the color. All right, so in the middle-ish here, there's a bar of is the scanner too far or too close from the object. It looked like I was too far away, but this is a little bit taller object, so I have to be kind of far away just to see it. So we'll try and, wow, we may not can get any of the scan done while I'm streaming. We'll try and get a little bit. Hopefully it'll let me do a little bit, but I don't know. Let's see. There we go. I'm going to go ahead and click start and let it do a little bit of scanning. So all of these green dots are pieces of data it has collected. Now, let's see. I did choose this model particularly. Well, here you go. See in the middle here, it's not seeing anything. Dark colors like black, really dark gray, really dark blues, they kind of hide the lines that it's projecting on there, and it can't see them. So you will miss some data. Trying to get over to the models so I can complete it. It didn't make a whole scan, but it got something, so I was going to, I don't know if I'll, all right, there we go. Complete. I was saying the dark colors, they hide the lines that it's projecting on there. So that can be a problem with these models. What I normally do, if I have a model that I need to scan, there is a dark mode. So object type here, there is a dark mode that will help. And so you can turn that on and it'll try a little bit harder. It'll basically project the lines stronger. If that doesn't help, you can coat the model. So this one, you know, there's a little bit of dark colors in there. That's about it. Everything else is not too dark. You can light the model better so that it's just brighter. You can coat it with, I usually use, there is a special laser scan spray, but I usually use golf marking. So like you spray this powder on your golf club head, and when you hit the ball, it'll mark, you know, it'll show where you were hitting the ball. Were you in the center? Were you off to the one side or not? That's usually what I use. Somehow you've got to get that dark color lighter. So those are some of the options. A transparent color gives the same problems, because if you have a clear piece of glass, that grid that you're trying to project onto it, it just projects through it. And so clear, transparent stuff, super shiny stuff, so it reflects the grid, or really dark stuff that kind of absorb the grid, those are trouble for these to scan. Let's look back over here at our stuff. So we got something. So what I have right now is, it looks like it made almost a whole revolution, but we didn't get the top of it. It was off the screen. So to get the top and these little pieces that we're missing, what I would do is I would maybe lay them down a different direction, you know, and scanning. So you can take multiple scans from multiple angles and then merge them all together. We'll do more of that when we're actually trying to scan the real thing. What I'm going to do right now is I'm just going to take the easy route out, and I'm going to do the one-click edit. So there's this one button that kind of takes all the default values and tries to fix this model. Right now, this model is just a bunch of dots. See all the dots? So I'm just going to do the one-click edit and let it do it. Should probably take a minute and a half or so, because I didn't get that many dots. And we're just going to, it says under a minute, so not even that long. Oh, Siri is talking. So what it's doing is it's trying to eliminate duplicate dots, merge ones that are really close together. Then it's trying to smooth the thing and apply an actual mesh. So this is what I got. With the little bit of scanning we did, I've got relatively decent. Now again, this particular scanner is kind of old. It can resolve down to maybe 0.5 millimeter in resolution. So it's not going to get super fine details, but you know, I can definitely tell what this is going to be if I take the rest of the scans and, you know, put it all together. I might not know it's Grant Hill, but I would know that it's a basketball player once I get the rest of it. So I think it will give us enough detail for scanning the hatch here, scanning the hatch area so that we can take that scan into Fusion. I'm not going to try that in Tinkercad, but I'm going to try to bring it into Fusion, and that's what we'll work on next time, is how do you take scan data and get it into Fusion and then use that. So we're using an actual scanner, a really low end but still actual scanner. There are apps on your phone, which I can't find my phone right now, but there are apps on your phone that you can use. The one I'm thinking of off first is Polycam. Let me see if I can find a website for that. Let me open new window. So Polycam. What this does is this will. Oh no, that's not the right Polycam. Poly.cam is what we need. So you can see this guy's taking a picture of the house that he's building, and it will generate geometry from the pictures. In that case, it was video. So it doesn't give you as high a resolution, but if you need just a general shape, even for our model here, we could probably get close enough to work with. It's not going to be super high resolution, but if you don't have a scanner, it might be what you have to work with. So I think Polycam has some free trials, and there are other model, this is called photogrammetry. And there are other pieces of software out there that might have free trials where you take pictures or video, load that into the software. I think Polycam actually sends them to the, I guess, the cloud. I don't think it does it locally because it's on your phone. So it sends it to the cloud somewhere. I'm gonna see if I can show you some that I've scanned. Oh yeah, here we go. All right, so here's some that I've scanned. In fact, I have the X30 in here. Oh no, let's do that one. All right, so here's the X30. Now these look pretty good because it's also taken all the pictures, like the actual images, and mapping them to the geometry it creates. So you know, this looks like you can definitely see it's warped underneath there, but you know, looks like, hey, there's a lot of geometry in there. But when I turn off the pictures, that's all the geometry you get, which is maybe enough. You know, maybe there's enough in there that you could take that mesh into Fusion 360 and work with it. We should get better than this from the scanner, even the old scanner. Here's some others. Here's Lady of the Mist. So walk around, take pictures. Again, it looks like, hey, there's a lot of detail in there, but when you turn it off, kind of, but there's not as much as it looks like. But I mean, this one, I walked around one time, I think one, maybe twice, I can't remember, taking pictures. It probably took Polycam app automatically can take the pictures for you at a set interval. It probably took 100-ish pictures. I loaded it, which in this case meant it loaded it to the Polycam cloud servers, and this is the model after, I don't know, the whole process probably took 10 minutes. Not very long at all. So it works pretty good on larger scale stuff, not so good on small scale stuff. And I don't know how much of it is free. I do have the paid version of it, so I don't know how much is free. If you really are, you don't want to pay, you don't want to send pictures to the cloud, you don't want to do any of that stuff, there is a, what is it called? Meshroom. So this piece of software You take your own. You don't have to use a phone. You can use a phone or a DSLR or whatever kind of camera you want. You take your pictures, as many as you want. You download Meshroom, which is also open source, so you can just download it. Everything stays local, which means that all the processing also happens on your computer. So where I loaded the pictures into Polycam, it sent them to the cloud somewhere, and then it sent me back the STL file, and the whole thing was 10 minutes or so. This one, everything happens on your own computer, but the whole process is free. It might take 4 hours, I'm guessing. If you had 100 pictures, it might take 3 or 4 hours, depending on what kind of processor your computer has, how much memory it can deal with. But this one, there's the Windows version. Last time they updated was 2023. All runs on all on your locally. It does have this. To fully utilize it, you need NVIDIA CUDA enabled GPU is recommended. If you don't have something that's compatible with that, you can only do a draft. So that is a thing that not every computer will actually run this. So that would be an option if you don't want to send your pictures away, like to the cloud, or you don't want to pay anything at all. Then there is Meshroom. And I think you can do some amount with a free trial in Polycam. I just don't remember what it is. Maybe one mesh or maybe a lower resolution mesh. I don't remember. But there might be some amount of free you can do in Polycam. All right. Next time we'll work on scanning the X30 hatch area so that we can take that scan into Fusion and start using that data to build out that hatch. Hopefully we can get something relatively close. All right, I will see y'all. It'll be Wednesday. No, today's Wednesday. It'll be Friday. So Friday we'll start doing that. I don't see any chat, so I will see y'all on Friday.